Okay, part 2 of the Intel manual. We are on 3.2 in it. We'll be reading about the overview of the basic execution environment. If you don't know how you ended up on this video, go ahead and pause and read why I'm doing this. To summarize though, I'm just reading something really complex out loud, talking to myself out loud, and I hope that is going to provide some value to all the people out there who are like me and learned a lot of crazy stuff on their own. Learning on your own is great, but it definitely has some challenges. So let's get started. It says any program or task running on a 32 processor is given a set of resources for executing instructions and for storing code, data, and state information. These resources, described briefly in the following paragraphs and shown in Figure 3.1, make up the basic execution environment for the 32 processor. So originally, I didn't want to read much about 32 processors, 32 bits. I don't think they even make computers that are or processors that are 32 anymore. But what I found out, and this is in the first video, I found out that the different modes, there's not much difference between the 32 and the 64. The 64-bit ones just add an extra 2 modes, and they exist for compatibility. So I need not to avoid learning about 32-bit processors because it looks like Intel's going to keep a lot of the same things. So it's just like learning about how they used to play basketball in the olden days. I mean, they played the game the same way. I think the processors are going about things basically the same way, but it's still valuable to study the past because, if nothing else, it gives you a stronger sense of the present and how we got here to the present. So, an Intel 64 processor supports basic execution environment of a 32 processor and a similar environment under IA32E mode that can execute 64-bit programs and 32-bit programs. Oh, so that is our first question, and this already clarifies stuff I learned before. So, in a 64-bit chip, you have 4 modes. What are they? And the right answer will involve you going back up and seeing that everything we read about the 2 sub-modes exists because this is the 32E mode. I mean, I read this sentence out loud, it just didn't click at all. So working backwards, the first mode you have in a 64-bit chip is 32E mode, and then you have system management, then real address, and then protected mode. So there's 4 of them, with one of them having 2 sub-modes. The basic execution environment is used jointly by the application programs and the operating system or executive running on the processor. Oh, that sentence is cool. It makes me think that you don't have to have an operating system to do something on a processor. I wonder what that would look like. Any task or program running on a 32 processor can address a linear address space of up to 4 gigabytes. And a physical address space of up to 64 gigabytes. Extended physical addressing in protected mode. See section 3.3.6 Extended Physical Addressing in Protected Mode for more information about addressing an address space greater than 4 gigabytes. So that's a question you guys probably can't answer, especially if you're entertained by me in this video. The question is, how often is the extended physical addressing used in programs? I'm just curious if this right here is a really rare thing. Basic program execution registers, the 8 general purpose registers, the 6 segment registers, the E-flags registers, and the EIP, that's the instruction pointer, register, comprise a basic execution environment in which to execute a set of general purpose instructions, and these instructions perform basic integer arithmetic on byte, word, and double word integers. These instructions handle program flow control, operate on bit and byte strings, and address memory. To learn more, you're going to read section 3.4, Basic Program Execution Registers. So that'd be a great question. What are the names of the basic execution registers? And I like to try to give hints here. So you got 8 general purpose ones, right? It's right here. You got 6 segment registers. You got the C flags, and then a very important thing, the instruction pointer. Now down here, x87 Fpu registers. The 8 x87 Fpu data registers, the x87 Fpu control register, the status register, and the instruction pointer register, and the operand data pointer register. There's a tag register, an opcode register, provide an execution environment for operating on single precision, double precision, and double extended precision floating point values. Word integers as well, double word integers, quad word integers, and binary coded decimal values. There's a lot to unpack there, but it sounds like x87 Fpu registers are large and intimidating. Okay, so when I see things like that, let's try to just get something from it. The question is, what register would you like to learn more about in the x87 Fpu family? Does that make sense? I mean, I just want to understand what an x87 is doing. I guess it's not basic execution, so it's something more. Oh gosh, I'm silly. I mean, it's right here. It's operating on single precision and all this other stuff that is related to the word precision. So there's a better question. How about that one? What are x87 Fpu registers used for? Now we got Mmx registers. The 8 Mmx registers support execution of single instruction, multiple data, operations on 64-bit packed byte word and double word integers. The Mmx technology programming environment. For more information about these registers, see section 9.2, the Mmx technology programming environment, for more information about these registers. And then it looks like you take this word and or acronym and you flip it. So there's Mmx and XMM. So XMM registers, the 8 XMM data registers, and the MXCSR registers support execution of SIMD operations on 128-bit packed single precision and double precision floating point values and on 128-bit packed byte. I wonder what a packed byte is. And I wonder how many bytes make up a double word. I remember learning that when I was learning the C language. There you go, it looks like it is 32 bits, aka 4 bytes. So the double word is 4 bytes. And that's just one example of what XMM registers can work on. So if a double word is 32 bits, I assume the quad word is 64 bits. So 4 bytes or 8 bytes. And to learn more about those registers, I guess we're going to read SSE programming environment. But not right now. Let's just get through this part. The Ymm registers, the Ymm data registers support execution of 256-bit SIMD operation on a 256-bit packed single precision and double precision floating point values and on another very big set of bytes, it looks like. The next one is bounds registers, each of the BND0 all the way through to BND3. Register stores the lower and upper bounds. This is associated with the pointer to a memory buffer. They support execution of the Intel MPX instructions. And then it looks like we have bound CFGU and bound status registers. These configures the BND CFGU, that bound CFGU configures user mode, MPX operations on bounds checking. And then that status one provides additional information on the #BR caused by the MX operation. I definitely am out of my league with those sentences. But I like pictures here. So everything we just read is broken into a picture right here. That looks pretty nice. So here's your address space. You have your group of registers for basic execution. You have Fpu registers. Let's just Google that real quick. Oh, floating point, that makes a lot of sense. So a bunch of floating point registers, and then you have all those other ones I have no idea about. So let's stop the video here. Look guys, we made it all the way to page 66 now. I'm going to keep changing the color up on this just to help everybody separate the things that we're learning in this manual. Thanks for watching.